what is psychometric chart. So in y-axis there will be omega. What is omega? Humidity ratio. Okay. This its unit is basically I think I have not written unit there, but unit is very important. This unit is kg per kg of dry air. Or you can say gram per gram of dry air, whatever. In this side, the temperature will increase, and this is actually dBT. Okay, you can write it as dBT. This is like actually the temperature that is measured by thermometer placed in the air or a sample. So we chart. Looking like this. Okay. This curve actually. So there are some lines. Okay. Suppose I am drawing lines like this. These lines are basically the lines of constant enthalpy. So you need to remember this, okay? This is very important. These are the lines of constant enthalpy. There are more lines. If you draw lines like this, somewhat not exactly but somewhat vertical lines, then these lines are called lines of constant specific volume. Constant specific volume. I told you this that this line, the projection on the horizontal axis will give you the temperature, basically that is dBT. So how you will get to know dPT? dPT means dew point temperature. How you will determine dPT from this psychometry chart? There is one process. Like if you draw, suppose if there is one process, suppose this is a process, okay. The process is going on, suppose this is from A to B and you need to determine its dPT. So what you will do, you have to extend this line towards this curve. Okay. Why I have done this? because when you extend this line towards this curve at this curve, this curve is basically called saturated curve. Okay, saturation curve. Saturation curve means RH is 100%. Anywhere on this curve, the RH will be 100%. So I have projected this line toward this curve. So this point, if you project this point vertically downward, this temperature will be called as dPT, dew point temperature. Okay, and how you will determine what will be the dVT of this process? See, at A, the dVT, just you have to draw vertical line. This will be the dVT of A for process A, and at B, dVT will be different. So dVT at B. Just I have given one sample curve. So sample process. For other process we will also see when we will deal with different processes in a psychometry chart. Now you can see like this, and how to determine WBT. I will explain it in the next class. So, and there are some more curves. Okay. Since I told you this is a curve of 100% RH, if you go away from this curve, in the same way, the RH will goes on decreasing. Suppose this is a curve for 100% RH. This will be curve. This curve will be for 80% RH. This curve will be for 60% RH. This may be 50% RH. This goes on decreasing. So in this way, RH decreases. RH decreases when you go in this way. So these are the things which you need to remember in psychometry chart. What happens? You have a mixture, okay? As I told you, you have a mixture of vapor and dry air. So, when you are writing enthalpy for moist air or the air sample, you have to take the enthalpy of water vapor and dry air also. So, I am writing enthalpy for dry air plus enthalpy of water vapor. And the sum of these two will give you the enthalpy for the moist air. So now, if you want to calculate the enthalpy of dry air, what is dry air? Dry air means only air part, no vapor, no vapor is there. So we know enthalpy, specific enthalpy basically. You know enthalpy, you can for ideal gas you can write enthalpy as Cp of dry air into temperature. This temperature is basically what? Dry bulb temperature. Plus omega times enthalpy of vapor, HV. Why we are writing omega? Because you know that omega is what? Specific humidity. Specific humidity is MV, means mass of vapor in some sample to mass of dry air in the same air sample. So I have to replace that H of vapor or quantity when you take into account, then omega will come in picture. Then this will be omega into HV. This HV I can write as, suppose I am taking this line as 0 degrees Celsius. Okay. This is 0 degrees Celsius line. This is actually TH diagram, okay? TH diagram. TH diagram. This is 0 degrees Celsius. Suppose this temperature is T degrees Celsius. So you can write HV as this entire process enthalpy. So that will be since the mixture will attain saturated condition at this point, so you can write HV as this part. This is what? Sensible part. So if you take this part from 0 to T, it will be Cp of vapor into T minus 0 degree plus, when you take this part, this is what? Latent part. So I am writing it as HFG at T degree Celsius. You don't need to consider this part, okay? But I can tell you the other portions also. Suppose you, suppose in exam they have asked you in terms of dPt or something like that. Actually, this HV value may vary. So there are several ways to calculate HV. This is one of the ways. I will explain the other ways also. Cp of vapor, if you calculate by that method, you know Cp. What is Cp? Cp is equals to R into gamma upon gamma minus 1. You can treat it as ideal gas water vapor. If you calculate the Cp for vapor, you will get this value as 1.88. 1.88 what? Kilojoule per kg K. Kilojoule per kg K, okay? This will be T. This T is this T only. dBT, dry bulb temperature, plus HFG at T degree Celsius. So this will be what? This we don't know, okay? So we have to keep T degrees Celsius only. We can't do anything there. Suppose I am taking all the values from 0 degrees Celsius only. So in that case, how will be the curve? The curve will be it will go like this, then this, and then it will move like this. So you need to drag this part to here only, then you will get the idea how we are writing HV. Or suppose I am drawing writing HV, means vapor enthalpy along this line. So what it will be? HV will be Cp of vapor. See, we don't have any sensible enthalpy part. We don't have any difference. So this will be actually Cv. This will be Cv. Cp of vapor into 0 minus 0 plus this part. This part is what? HFG at 0 degree Celsius. Okay. Plus Cp of vapor into this part. This part you can see this is T only, T degree Celsius only. And this is what? 0 degree Celsius only. So if you take the difference for the enthalpy, this is what? Sensible enthalpy only. This is latent enthalpy. We don't have sensible enthalpy for the fluid conversion to okay. We don't have sensible enthalpy for this one. We have latent enthalpy and this sensible enthalpy. So this will be T minus 0. T minus 0. So it will be, this part will get cancelled. This is 0. So you will be left with HFG at 0 degree Celsius plus Cp of vapor into T. This is dry bulb temperature. You know, if you see from the steam table, this HFG at 0 degree Celsius is what? Around 2500. So this is HV. Basically, if you see the formula in many books, they used to give this value for HV because they treat this as most accurate way of writing the things. You can write HV in one more way. How? If you write in terms of DPT, dry bulb temperature, you can write this as okay. So this temperature I am treating it as DPT, dew point temperature. DPT. If you write the enthalpy for this process, you can write this enthalpy as HV is equals to, for B, HV for this process B will be Cp of vapor into this T dPt minus 0. So T dPt minus 0. This is the sensible part. Now comes to latent part. So it will be HFG at T dPt. We have covered latent part. Now cover the sensible part. So plus Cp of vapor into this temperature. This temperature will be T minus T dPt. So T minus T dVt. So this is also one of the way of writing enthalpy of vapor. Okay, I am closing this all in bracket. Three ways we have seen how we can calculate the enthalpy of vapor. So this one we have calculated for T degrees Celsius. So this is for A. Okay, so I am writing here A. This is for 0 degrees Celsius. C. So take it C only. This curve as C. So if you, I said that there are three ways to calculate HV. This way, and this way. But in most of the book, if you see, they have given HV this value. So let me take this value only. Then in that case, enthalpy of moist air will be this part, Cp of, what is Cp of dry air? Cp of dry air, basically we used to take it value as 1.005 kilojoule per kg. So I will directly write it 1.005 into T plus omega times this one. This will be 2500. This is in kilojoule per kg, okay? Kilojoule per kg. And Cp of vapor is 1.88 into T. So this is the complete formula. This is the most important formula. You have to use it in several problems and several processes also. So this is one you have to remember. You have to keep in mind this formula. And remember the unit. Don't play with the unit. This is in kilojoule per kg. Okay, this is in kilojoule per kg. This is in kilojoule per kg. Directly put temperature in degrees Celsius. Don't try to take it in Kelvin, okay? Directly put in degrees Celsius. Here also, this is in kilojoule per kg. This is in degrees Celsius. This is in degrees Celsius. And this is in kilojoule per kg. So this is the way how we used to determine the enthalpy of moist air. So this is all for this class. In the next class, I will explain about the different processes that we see in the psychrometry chart, and afterwards, if we have time, we will deal with some of the problems that came in the competitive exams. So if you feel any doubt in this, how we have calculated the properties or any properties, one property I have left, I will discuss in the process when I will deal with the process. But as of now, if you feel any doubt in these properties, please feel free to mention us in the comment box. We will reply to your every possible queries. And for then, thank you friends.